Welcome, my name is Ms. Shauna Smith, and I've been teaching here at Pensacola Christian Academy for the last 8 years in high school math classes. I've had the opportunity to video Algebra 1 and Algebra 2 for Abeka, and I've gotten the opportunity to teach geometry and pre-calculus as well. So today we're going to look at the essentials of a high school math class, and I hope that today's session will give you a few ideas that you can implement into your classroom this year as you're teaching different levels of classes in the math classes. As you're going through those different classes, we're going to talk through some concepts that you may be able to implement, may give you a fresh take on some of those things that you're already doing. Now, if you're to think through some skills that you would need to teach a math class, some that come to mind would be you have to be able to think on your feet. And if you're thinking on your feet, that's definitely going to include catching errors that either you as the teacher may be making in your math or that your students are making. More often it's catching the errors that your students are making, but we have to constantly be thinking about what the different processes are that we're teaching, as well as looking at what the students have done and what we are doing. You also have to be very patient, don't you? Because you know that the students aren't going to understand it the first time you go through it, and reiterating things and reviewing concepts. But you also want to be encouraging to your class. And so those are some skills that we're going to be talking about as we go throughout today, some ideas as you're teaching your classes. We're going to kind of break this up into how you would prepare for your class, how the class order actually goes, and then some ideas on how to teach the concepts themselves. So let's start by actually looking at the lesson preparation. What do you do to make your preparation run smoothly? How do you prepare so that your class actually runs smoothly itself? So let's start by looking at actually working through each of the problems in the section. Now, I say that, and I'm going to say this as well. You may be teaching multiple classes that you're preparing different lessons for. So when we're talking through these concepts, I'll give you a couple of tips if you are in that boat where you're having to prepare lots of different lessons. But if you're teaching maybe 3 or 4 different subjects, this is a really helpful thing to do, to actually work through the problems. Now, why we're doing that is so that you understand the concepts that are being taught. I know I've had the opportunity of teaching several different classes there, and the first year teaching those classes, you aren't 100% sure what it is you're teaching the next day at times. So you're preparing and you're studying to then turn around the next day and teach that concept that seems brand new to you maybe. And so as you work through those problems, you're understanding the concepts better yourself. And in doing so, there's a couple of things you want to pay attention to. One of them would be the terms, and thinking through the terms that are in that section. You may want to even look up those terms online so that you can get a broader view than what's just in the textbook. So that's something that I would recommend doing, especially if it's a new class you're teaching. You'll also want to pay attention to the math steps. So as you work through the problems, and we'll talk about that in a second, you're wanting to think through what are the steps themselves that take to go through the problem that I'm doing every single time. And in doing so, you will also notice there are key differences in the different processes that are happening. And so you'll want to think through what is something I can tell my class that is a key difference. If you see this in this problem, this is what you do. So as you work through the problems, you'll actually want to work through the actual problems you're going to assign your class. So you've worked through maybe example problems. Then you want to work through the practice problems that you assign, as well as the homework problems. Now, why do that from the beginning? I do that actually from the very first day I'm preparing for a lesson. I'm thinking through at day 1, I'm going to assign what homework that evening, and I'm going to work through those problems before I even assign it. One of the reasons is you're able to catch what the key differences are that you will assign them to make sure that you've actually fully prepared them for that class. So if you're thinking about it, decide, once you have figured out what those problems are that you're doing for practice and homework, decide what the example problems really should be. There are times that you've gone through and worked through the example problems that maybe are in the textbook, and then you go through those practice and homework problems and you realize I've picked the wrong example problems to do because it doesn't fully prepare my class for whatever the problems are that I'm assigning for them to do. So if that happens, then maybe pick one of the classwork problems that you've already done and use that as an example problem. There's benefits to doing that because the students don't have the problem worked out ahead of time. And so they're actually having to think through a little bit more with you. But don't waste your time. The practice problem that you're now replacing in place of one of the example problems you did, maybe take that example problem and use it to review the concept later on in another lesson. Maybe jot that note down or put a sticky note there for you. All of those little time-saving things will help your lessons run smoothly. You can bring those terms back up and those concepts back up in review later on. But you're making sure that that lesson fully prepares the students for whatever it is that you're going to assign for them to be able to do. So that's something I would recommend. Actually work through the problems. Now let's go back and reiterate what happens if you are teaching multiple classes and you're having a brand new preparation for each one. That's where a solution key comes into play. You can use a solution key to accomplish very similar ideas to you actually working the problems without you actually having to work them. You can think through the concepts. It saves time to think through the problems ahead of time, so in class you're not having to think through and figure out where are their errors. You'll catch them faster. So that's something I would recommend as you're working through it. Now let me give you a couple of pictures of notes that I've done. I have found this helps me so much whenever I'm doing a new class. These are some pictures of Algebra 2 notes, and the first one that you're seeing here is going to be where I have notes for my actual lesson. So you can see I have the problems worked out, I've got some examples figured out and the terms listed and what I'm going to explain, and then I also have my practice and my homework problems already worked out for the lesson. So it's all one package there. And I keep these notebooks so that if I ever teach a class again, I've got them and I can reference them. I may work the problems out again the next year I teach it, but the concepts are there for me to use and I don't have to rethink how I did the problems before. So every class I've taught, I have these notebooks that I keep, and then I don't necessarily keep them from the classes the second or third year, but those first years, maybe the second years, if I've changed a couple of things, I keep these notebooks and it helps save me time in future years that I'm teaching. So it's worth the time putting the effort in the first time you do it, but then you can keep it from year to year. Now, once you've done that, let's actually think through how to build the lesson itself. You know, the math class is more than just explaining the steps, but you want to make it so that the students are understanding it and enjoying it. So this is where building your lesson really helps. See if you can come up with some examples that actually include your class. I've noticed whenever I do this, the students are with me even that much more. One of the ways I'll do it is going through illustrations that actually include students from class. Sometimes word problems that are in the book include the names of students that you may have, and maybe just make it their word problem. And if that happens, it makes it that much real to those students. Or you may have a ridiculous example that you're using with 38 watermelons, and then a student in your class is the one that's the farmer. Have all of those things and include the students in your class to make it that much more of a fun class for them. But you may also want to consider what are your students' actual interests. Instead of it being just a ridiculous problem, maybe your class is really into track and field. I had a class this past year who was a very athletic class, and so most of the students in this one section had been on track and field. And so when we got to permutations and combinations, we were discussing the podium, first, second, and third, and using students from the class. And so if you can illustrate using students in your class and you can actually include student interests, it piques their interest in the math that they're learning. And this is probably one of those things that you're going to have questioned of you if you've been a math teacher for any number of years. They will ask you, where am I going to use this in everyday life? And to that, if you have an answer, it really does mean something to your students. So what I would recommend is, as I'm preparing a lesson, especially if it's a theoretical lesson, not so much a practical lesson that they see obviously where we use it. If you can look up where are these things actually used, it may be that it's the logic that you're teaching them, like in a geometry class. They may never need to prove that a triangle is congruent to another triangle, but they sure are learning how to think. And so using those little illustrations and showing them, hey, this is where we use this in everyday life. This is how it's going to benefit you. This is something that you can try to incorporate in your class to avoid them asking you that question because you're already telling them. So if you can build that into your lesson, that's a great thing to do. Once you've done all of that, one of the last concepts as you're studying is to do this. Study so that you don't have to be tied to your notes. Now, if you need to use your notes to get the problems, that's one thing. But if you have worked through those problems, you probably know the steps and you don't really need to reference your notes to see what's the next step that comes. Think about how Jesus taught. If you teach with authority, that comes from, and the students can pick that up, when you don't have to look at your notes for every little thing. So if you can teach with authority like Jesus taught, then you're able to kind of convey that to your class. Jesus taught the Sermon on the Mount, Matthew 5 through 7, and at the end, The Bible says, "For he taught them as one having authority and not as the scribes." The people noticed a difference in how he taught compared to how the scribes taught. And so if you're able to teach with authority, that comes through, yes, rapport with your class, but also the idea of them knowing that you do know what you're talking about. So if you're able to study that way, that really does lead them to do that. One of the other things to think through is as you're teaching, if you'll teach from known to unknown, and we'll say this multiple times here today, if you'll teach from known to unknown, you'll find that you don't have to use your notes as much because it's a natural progression. God's created math with that natural progression so that it builds one on top of the other. And showing them that really does help them remember things as well as you as you're teaching. And so those are some ideas as you're studying to try to make that happen. One of the last things you'll actually do as you're preparing is decide how much theory you need to actually show your class. So let's compare a couple of things. One is deriving of an equation that's going to be used, like for instance, the quadratic equation. You can derive that formula for your class and show them where to use it, or you can just show the class how to use it. Now, for some classes, they really do need to see where it comes from. I have had students comment before that in geometry, they understood things because it showed from step to step how things worked. And when they had taken algebra, they didn't understand it as much because they didn't know the whys behind it. Those intellectual students sometimes really do need that deriving of an equation. But if the majority of your class is not one of those students, it's probably better to just show them how to use the equation. So you have to choose, and it may change from year to year. One of the other things you kind of need to think through is this more of a practical or a theoretical lesson, and try to see where can I make it a practical lesson. Math is not just studying math for math's sake, although some students do enjoy that. The ideas are that you want it to make it as practical of a class as possible. And so if you can, do that. God created math to describe his creation, but it also benefits mankind. And if they don't see that benefit, then it makes it not as easy for them to understand, and also maybe not even seem like worth their time. So if you can draw those in, it really helps. Something else to think through are your students. And I've kind of illustrated this already, but if you have intellectual students versus an average class, I've had classes that were full of students that wanted to know the whys, and it really helped them when they could, versus students that just need to know how to do it. And so you'll have to determine, how am I going to include both of these students in each lesson? Not every class is made of all one type. And so you want to see, can I get a little bit of the whys included so that my intellectual students completely understand? Can I get the average students involved by helping them understand how to use the process? All of that goes into play. Now, I've explained all of these things. Actually, preparing for the lessons don't take as long as it sounds. So you're doing most of these concepts as you're thinking through your examples, jotting down little notes. And hopefully those are some tips that'll help you as you're actually preparing to walk into a classroom. Now that we've talked through how to actually think through your lesson preparations, let's see how the actual class order goes. One of the very first things you're going to do as you're actually thinking through that process of the order of the class is go through homework check. So after the tone has rung and your class is seated, you're thinking, how can I check their homework? A lot of times I will walk around the classroom and check the homework so I can talk to the students individually. There's benefit to also having the students pass the homework forward because oftentimes that's easier. It's according to what class you're teaching. If you have loose leaf paper, maybe that's something you can just have them pass it forward. If there's notebooks though involved, then it may be easier for you just to walk around. My goal is to make this fast as I'm checking, but also to make sure that I've paid attention to a couple of things. Let's start off with the ideas of accuracy and completion. Students want to make sure that they are doing it in a quick time. Most students are not really wanting to spend an hour on their math homework, but you also want to make sure as you're checking it that you're checking for accuracy. So students need to have their homework complete, and I think we would all agree with that, but the accuracy is important as well. And so one of the things I do to try to make sure that both are happening is I'll get one or two problems and walk around and make sure, hey, this answer is right, or this answer, why don't you check it one more time, to point out the fact that I am paying attention to what they actually wrote. And I'm looking for completion. Now, depending on what maybe your requirements are with your school, this may or may not be an option, but one of the things to consider if you have an option is grading versus not grading your homework. So if you're thinking through the actual grading of it, this is something that I would recommend. I would recommend not grading homework for this one reason. Whenever you're doing homework checks, one of the things that your students, as we're going through and actually checking the homework is to make sure that they have an opportunity to learn from any mistakes and before they actually have to have it graded. So if you give them the opportunity on homework to make a mistake where they can fix it, and instead of grading the homework itself, giving them the opportunity to fix it there, and then have maybe that opportunity for a graded item on a quiz that gives them chances to learn and not worry about getting mistakes on homework. You're wanting them to learn. And so if you have an opportunity where you don't have to grade the homework, it gives them that little wiggle room. So yes, they missed it on homework, but they can fix it and learn from it before it's actually a graded item. Now, if you are grading homework, that's something that you'll have to kind of think through. How are you going to actually check homework so that you aren't necessarily giving the answers? My recommendation is don't grade the homework. You probably have enough that you're grading anyway as a math teacher. So if you can, avoid grading homework. It gives them an opportunity to learn from their mistakes, and then it saves you time because you don't have to grade it. Something to think through as well is during this homework check, what's happening in your classroom. I'm trying to get my students ready to actually present the problems. So I will go through and either write names on the board or have it so that they know what name is going to be doing which problem. And so my goal is to have the students at the board working the problems while I'm checking homework. And then the students at their seats, I give them some sort of a classwork problem. Sometimes it's to study a section. Sometimes it's to work on, if you're teaching from the Abeka Algebra 1 or Algebra 2, they've got review lessons right there built into each lesson. And so you can go through and actually have some of those problems that's for classwork that they already know how to do. So my goal is to keep the students at their seats busy, but also have students at the board so that I'm able to have the presentation of the homework immediately following homework check. My goal is for homework check to take about 2-3 minutes max. That way I can get started with my class. And I'm looking to see who at the board is done first. So we may go slightly out of order depending on time and how long it takes them to put the problems on the board. Once you've done homework check, then you're going to look through the actual presentation of the homework. This is where the student presents their own work. Now, why have the student present the work? Because it teaches them how to teach and show the math processes so that the peers in their classroom can understand, teaches them how to talk with the terminology that you've already been teaching them, and it really does help to catch errors if the student is the one presenting and then you're watching and the students at their seats are learning. Sometimes it's hearing it just slightly differently from the way maybe you as the teacher would say things that helps students at their seats learn. And so having somebody else present it is good. Now, one of the things I would say is don't let them just say, here's the problem, here's my answer, but actually talk through the steps. In doing that, then students who were even absent the day before should be able to pick up the concepts. And that's always my goal. If students at their seats who were absent the day before can figure out how to do the problem because of what was said in the homework presentation, then that student explained it well. Now, how do I catch errors? You want to catch all of the errors that happen in the homework so that the students at their seats and the students at the boards know what errors to avoid. The goal is to have not me as the teacher catch it, but the students at their seats catch it. Here's why. The verse, Proverbs 27:12 says, "A prudent man foreseeth the evil and hideth himself, but the simple pass on and are punished." My goal is for students who maybe even didn't make an error can catch an error so that they themselves know what errors are common and can avoid them themselves. Now, we're not talking about evil, we're talking about error, but the same concept follows in a math class. So if the students can avoid those errors themselves, it really does help them quite a bit. So that's something that I would recommend. Try to get the students at their seats to catch the error. After every question, I often will say, are there any questions or comments? It gives the door open for two things. Any errors need to be corrected, the students can say there's a comment, or if a student isn't sure where something came from, there's a question. But I don't want the students to know there is an error. So if I ask that after every question, then they're looking automatically regardless. What you don't want to do is to move on and have the problem erased, and then there actually have been an error. So your goal is to make sure you catch the errors as well, and the students at their seats can catch the errors. So it's kind of hand in hand that you're working with that. Something else to think about is how to involve all the students during this homework presentation. And this is where we kind of lead in. The students at their seats are catching errors. There's something else that it can do. Most of the time, you don't have enough boardroom to put up every single problem the students did for homework. So that's where you can give 1 or 2 problems that are just like other ones and just have students at their seats answer the questions and answer whatever they got from those problems. So you've illustrated the example problems at the board already, and now they're just giving answers. We're going to watch a video of Mrs. Odom teaching a pre-algebra class doing just this. She's going through the presentations and watch to see how she actually does include the students at the seats, how she gets answers from all the students, and she points out some errors so that the student who is presenting can figure out what they did wrong and fix it.
Let's go ahead and check your homework from last night. Homework was on page 170, and we worked problems 1 through 20. Let's start with number 1. Michael, what do you have for this answer?
For number 1, I got x is greater than or less than and greater than or equal to 25.
You got it. Greater than or equal to 25. Number 2, Noelle, you did this problem. Tell us how you did this one.
So I divided the -4 by both sides, and I got m is less than or equal to -13.
Okay, but do you remember what we talked about in the last lesson? If you divide or multiply by a negative, remember those bells going off in your head? What should you have done?
I should have switched the sign, so it should have been greater than or equal to.
Good. You should have switched that sign. So it would actually be n, or m, is greater than or equal to -13, because remember we flip that symbol if you divide by a negative. Any questions on that one? Great job catching that mistake there, Noelle. Number 3, Dylan.
So it would be 48 is greater than 12y. So first I checked if there was anything to simplify, and there wasn't, so I had to isolate the variable. So I divided both sides by 12, and I got 4 is greater than y, where y is less than 4.
Good. Now, would I take both of those answers? I would. I would take both of those answers, but great job with switching those and making them correct. Remember, if your inequality is pointing towards the y, it needs to stay pointing towards the y if you flip those. Okay, any questions on that? Cole, did you have a question on that one? You ready to go for number 4? Number 4, what's your answer, Cole?
Number 4 is a is less than or equal to -1.
You got it. Number 5, what's your answer for this one, Jack?
K is less than or equal to 4.
Okay, now, did you notice some of those things that she did? Something that was very good is she pointed out what they had done the last lesson, but she didn't necessarily reteach the lesson. And that's the whole goal whenever you're doing a homework presentation. You don't want to reteach the lesson. Your goal is to actually teach the lesson the day before and use this as a review. And so if you're stuck where you didn't have enough time to teach a lesson, you want to avoid this snowballing effect of the homework presentation becoming a reteaching of the lesson before, and then you not having enough time to teach the lesson, and it keeps on going. I know I have had this happen before. One of the fixes I've found is if you're finding that the homework presentation is taking a long time, something that you want to watch is to stop the homework presentation, go through one of the problems and say, here, let's go through this, and then tell the class, hey, tomorrow we're going to go through this again. As a review, I want you to make sure that you're watching this carefully and give them a chance to kind of think about it, practice it the next day, but stop the homework presentation. Your goal is to make that homework presentation last no more than 5 to 10 minutes because you need enough time for your lesson itself. And so if you can avoid that from taking so long that you're reteaching the lesson so you don't have time to teach that day's lesson, try to stop it. Try to make it so that you can get the lesson in so that you can get back to the normal routine of not reteaching a lesson during a homework presentation. Now, let's go on to the next concepts. Once you have actually thought through those homework presentations, the students are on board, they understand, now's the time that you're going to review or give a quiz. Now there's 2 types of reviews, and we'll watch an example of each from Mrs. Odom, but with the reviews, this is something that you want to think through. How am I going to review my terms? And then we'll look at how to review the problems in a minute. For the terms, something to think about is you want the students to understand what each of the terms means. And so we're going to watch a video of Mrs. Odom reviewing these in just a moment. When you're watching this, note how she says certain things because the students are not understanding the terms. The terms are important in math so that they can speak in a way that is understandable, but they understand what you are saying as well. If you use terms that the students don't understand to be able to explain a concept, that kind of defeats the purpose of them understanding. So them understanding the terms is an important thing. So we'll watch a video of Mrs. Odom doing that now.
We're going to start by doing a little bit of review. I told you your test is in lesson 30. So we're going to start right now by even covering a couple of those topics in the review. So let me ask you this first question. And if you don't know the answer, I would encourage you to write down part of the question so that you will know it if you see it again. Number 1 for my questions. Ready? Talking about dimensional analysis. Dimensional analysis includes multiplying by conversion factors written as what? Let me say that again. Remember, dimensional analysis multiplies conversion factors, but how are those conversion factors written? Dylan?
As a fraction?
As a fraction, or another word is as a ratio. So make sure that you know that the conversion factors are written as ratios or fractions for dimensional analysis. Very good with that. What about the metric units? We've been talking about those already, right? Which metric unit is used for length? Students watching and Jasmine. Which one is used for length? Jasmine doesn't know. Students watching, hopefully you know. Natalie?
Meter.
Meter, very good. We use meter for metric units, right? So be careful about that. What about capacity? What metric unit uses capacity? Jack?
Liter.
Liter, very good. Like a 2-liter bottle of soda, so something like that. What about mass? Which unit is for mass, Dylan?
Gram.
Grams. So not a lot of students here knew those answers. You know what you should have done? You should have put those in your notes because you may see those again. So if you didn't know them, make sure that you know them soon, especially with that test coming up.
Now, we're also going to look at her reviewing of the problems. So this is where most of the review is going to happen, is actually reviewing problems that you have taught previous. You want to make sure that you are methodical about this, that you don't accidentally miss concepts as you're reviewing throughout leading up to a test or leading up to a quiz, that you've gone through and taught the different concepts and then also reviewed them before them. But you want this to be a time where the students are actually telling you more than you are telling them. Watch a video of Mrs. Odom doing this as well. If you note, she goes quickly through review. That way she keeps the students on their toes and she's reviewing a fairly hard concept that the students were struggling with. That's something that if you can keep the students telling you, but she gives them leading questions to lead to the next concepts, that way the students ask those questions as they're thinking through the problems as well. So we'll watch a video of her now.
Let's work this problem together just because I think this is a good review for us. If I have negative 15 is less than or equal to negative 2b plus 3 is less than 5. Clara, help me out with this because you were almost there. So we're just going to finish it out. What did you have to do first? What's in the middle here? Can I simplify anything?
You get b by itself.
But I need to get the negative 2b by itself. So what am I going to do with that 3?
You're going to subtract it from...
Subtract it from all 3 sides. What's negative 15 minus 3?
12. Negative 12.
Not negative 12. Remember, negative 15 minus 3. Do I have any rules for subtraction?
Negative 18.
So change it to addition, change that. So negative 18 is less than or equal to?
2b. Negative 2b.
Good.
And that's 0, so...
Is less than, what's 5 minus 3?
2.
2, okay. How am I going to get b by itself?
Multiply by 2. Divide by 2.
Divide by?
Negative 2.
Divide by negative 2. Did the bells go off in your head? They should have because you're dividing everything by a negative. So what would I have on this left side here?
Negative 9.
2 negatives make a?
Positive.
So it would be?
9.
Positive 9. And this, instead of being less than or equal to, would now be?
Greater than or equal to.
Negative 2b divided by negative 2 is?
B.
And then this less than now becomes a?
Greater than.
Greater than. And negative 2 divided by, 2 divided by negative 2 is?
Negative 1.
Negative 1. All right. Now, this is where we were just talking about with Jack's question. Does this, can I use greater thans? I need to use
Less than.
I need to use less thans, don't I? So when I use less thans, what idea am I going to use here?
What?
What idea? Think about when I was talking about in the last lesson with
You're
my
gonna
name
mirror.
tag. What are you going to
Mirror.
do? Mirror image. Very good. So let's mirror image this. What is it going to be?
9 is,
If 9 was on the left, it should now be on the
right.
right. Okay, so this one was on the right, so now it should be on the
Left.
So -1.
1
What symbol is closest to this?
greater than.
So it should now be a
Less than.
less than. Put that B right in the middle. This symbol now becomes a
Less than. Equal to.
less than or equal to, and then 9. So that would be your answer. -1 is less than B is less than or equal to 9. Any questions on that one? Number 32 should be -33 is less than U is less than 12. Number 33, your equation should be 4B minus 4 equals 72, and Joey jumped 19 inches. Number 34, Marvin and Eric both sold candy bars, so your equation would be 6M plus 4 plus M is equal to 144. Marvin sold 20 bars and Eric sold 124 bars.
Now let's pretend that you were giving a quiz that day. If you're giving a quiz that takes the place of all of these reviews that we're talking about, you may want to review some terms very quickly afterwards, but a quiz in and of itself is a review because the students are now getting graded for the items that they have already done in the past, and you are going to go through it there for them to see it. So if you're giving a quiz, I wouldn't do a full review as well. It takes up too much time of your class. So after you've gone through either review or a quiz, it's now time to look at the lesson. We'll talk about the lesson a little bit in detail in a little bit, but I want to point out a couple of key ideas here as you're teaching. One of the main things is you'll do an example where you're going through it step by step, known to unknown. So you've already prepared your lesson, you've thought through how I can connect it to things either with the class or things that they already know, and I'm trying to teach it in such a way that the students will understand it. So I'm going from known to unknown. Now, as you're doing this, you're also going to think through 1 or 2 more problems for the students to actually help you with. We'll talk about actually teaching the lesson in a little bit, but it's more than just one problem. Your goal is to try to get at least one more problem, depending on the length. Now, with a geometry proof, you may not have time to do 2 proofs in class where the students are helping you, depending on the length and how well your students think with the proofs. But in an algebra class, your goal is to do at least 2 problems for them. So one that you're teaching all the different steps and one more for them to help you with. After you've taught the lesson, now it's time to practice it one more time. This allows them to have the opportunity to master those concepts that you've been teaching. And so as you're going through and actually going through the lesson, your goal is to prepare them for this practice time. If they aren't prepared, I would stop it and go back and reteach the concepts so that you don't have a long homework presentation the next day. Most of the time, though, if you've gone through and prepared your lesson, your examples have prepared them for this practice time so that you should have time for the students to actually present these problems one more time like you would during a homework presentation. So your goal is for them to master it, get a good handle on it, not assign so many problems that they can't get it done, but to get those problems that they do get done well, and they are able to be successful at it. Use this time to kind of gauge how well does my class understand the concepts before you go and assign their homework. So if you do need to fix a concept, I would stop the review right here with the practice and say, hey, let's go through this one more time just to make sure they have it down. That's the whole goal. And at the very end of class, you'll give the homework assignment. With the homework assignment, the whole goal of an assignment is to actually help the students practice the problems after they've walked away from it for a little bit. So they've walked away, they've had other classes, they've had other things they're thinking about, maybe sports practice. They sit down to do their homework, and now they have to remember something that they did in class. It helps build long-term memory. And so your goal is to have them be successful at their homework because you prepared them all the way through the lesson, through the practice problems, all the different things, and they are successful at it. So that's something just to be aware of whenever you're working through with the homework. The other thing the homework does is it allows you as the teacher to be able to tell where are those problem areas that I need to have a bit more explanation. If I need a bit more explanation, I'll probably catch it the next day as I'm doing my homework presentations, and I can see, hey, this is a common error. I need to explain why, and so you can fix it there. The goal as you're teaching a math class is for it to go pretty seamlessly. So you've thought through all those preparations and you've thought through those orders and you know what I'm going to do each of the different times of the day. And as you're doing that, you'll be able to kind of gauge how well my class knows by having all these extra practice, homework, and having them actually present the problems. So you can see where the errors are. Now let's spend just a bit of time talking about how to actually teach those math concepts. We're going to look at two, mainly algebra concepts, and then we'll talk through a little bit about geometry proofs. So let's take a look first at the algebra concepts themselves. When you're teaching, and I know we've said this already, teach it from known to unknown. Now that's more than just the concept itself. Sometimes it's a brand new concept that they may not have anything that's extremely known to them about that concept, but that's where you can do this. When you're teaching the terms, you can still point them back to some things that they have already had experiences, whether life experiences or math experiences, to help them say, hey, this is like something you already know. We're going to watch a video here in a little bit of Mrs. Odom teaching about equations for the first time for her class. And it was taped while COVID was going on. And so in her classroom, the students are very familiar with the term isolation, which, if you think about it, is really important for an equation. And so she brings up some terms that are new to the students in math, but are very familiar to them in everyday life. And she draws that conclusion so the students are drawing that to something they know. And if you can do that, it really helps quite a bit. So point back to past concepts if you can. And a lot of times you can. So you can point back and say, hey, this concept is just like when we did this other concept here. It may not be exactly the same, but it may be similar. So if you're able to point out, hey, these concepts work the same way as something we've done, see the differences here, and point out similar concepts. Like we said before, God created math to be built one on top of the other, and you can learn it just like that. And so if you're able to build that, it helps the students see that logical progression from one thing to the next. Other things to consider as you're teaching. Teach it step by step. So as you're thinking through and actually preparing, you've thought through the steps yourself, maybe see if there's some ways that you can actually help them remember the steps. That's not always possible. It doesn't always have something that you can use to illustrate it. If at all possible, though, make sure that you write down the steps for the students to be able to copy down. What I tell my students is if you'll write the steps that we're doing in your notes and practice them with those steps as you do your homework and as you do practice problems and review problems, you'll memorize the steps. That's what you want to do. How do I start this problem? I'll know the steps to be able to work it through, be able to think through the different concepts because I know the steps. So if they can memorize the steps, that's important. So as you go through it, try to stress that. Another thing to think through is the whys behind what it is that you're teaching. Not everything can you teach the whys behind it, but if you can, try to do that. Remember that student I was talking about, they understood geometry, but they didn't understand all the steps in the algebra because they didn't know all the whys behind it. Now, not every student is going to understand all the whys, and not every concept can you say that with, but if you can, try to. So as you're teaching those lessons, teach it step by step, teach it from known to unknown, and really stress those steps for the students to practice them. And even as you're reviewing concepts, try to use the same steps you gave them. So all of that goes hand in hand. Now, we're going to watch a video of Mrs. Odom teaching that lesson with the algebra, that first lesson with the equations, so that pre-algebra class. We'll watch that now. Watch how she explains and watch how she engages her class in showing them, hey, you know this concept, this is where we're going to use it now.
Now today we're going to start with equations and solving equations. So the note I want you to write down first in your notes is the word equation, an equation. What is an equation? Well, here is your definition. First off, here's how you spell it, equation, and then here's your definition. Remember, make sure that you're taking notes. It is a mathematical statement that uses an equal sign. Remember, your notes are beneficial to you, so make sure that you can read them, but make sure that you take them quickly. So it's a mathematical statement that uses an equal sign. And this may be something to help you remember. When you look at equation, the first couple of letters, equa, kind of look like equal, okay? And so an equal sign is an equation. So anytime you see that equal sign, it's an equation. Now what that equal sign does is it tells you a relationship between two parts. For instance, it shows how they are equal to each other. If I were to give you something like this, x minus 10 is equal to 10. Well, what I'm saying is I'm saying that this part of my equation is equal to this part of my equation. That's what an equal sign is. Anybody remember from the last chapter what little word meant I would write an equal sign when I was translating? Maddie, what little word meant that equal sign there? Is. So what I'm saying is I'm saying x minus 10 is 10. And that's what that equal sign is. It's saying that those two sides of my equation are equal to each other. So what we're going to see here is in our equations, we're usually going to have a variable. For instance, my variable in this case is x. That variable is an unknown. I don't know what number that is. So my goal is to figure out what is that variable, what is that unknown. And that whole idea or that process is called solving equations. So solving equations is figuring out what that variable is. All right, so let me give you your steps. And remember, like we've talked about with maybe order of operations, when you follow the steps, you get it right every single time. If you don't follow the steps, then you don't get it right. So same thing with this chapter. Follow the steps if you want to get it right. Here's your step number 1. Step number 1 is simplify both sides. Simplify both sides. So what I'm going to look at, did you write that step down? Simplify both sides. I shouldn't have to remind you to do that. You're going to look at x minus 10 and you're going to see, can I do anything with that? Can I simplify? Do we know what x is? Yes or no, class? No, it's unknown. So can I subtract 10 from something that we don't know? Your answer would be no. So I cannot simplify the x minus 10. Can you simplify 10 any further? No, you can't. So in this case, step number 1 is already done for us. But in a lot of cases, you're going to have to do step number 1, where you're going to have to simplify. Step number 2 is this. Isolate your variable. Isolate your variable. Isolate your variable. Now, when I say the word isolate, okay, if I say I am isolated from the rest of the class, or if I'm in isolation, have you heard of that before, isolation? If you are isolated, you are all by yourself, no one else is around you, you are completely alone. That's what isolated is. So when I say isolate the variable, here's what you need to think. You need to think, I need to figure out what variable I'm looking for, and I needed to get it all by itself. Nothing can be around it. Okay, that's what isolated is. Nobody is around me. I'm isolated. Does that make sense? So now I'm going to look over here at my equation, and I'm going to figure out where is my variable and what is beside it. Well, my variable is x, and beside it I have a minus 10. So I need to get rid of that minus 10. How am I going to do that? Under step number 2, I'd encourage you to write this down. Use inverse operations. Use inverse operations. Use inverse operations. Now let's talk about what an inverse operation is. I'm going to move this up so I have a little bit more room to write here. If I'm talking about addition, all right, what is the opposite? Because that's what inverse means. What is the opposite of addition, class? Subtraction. Subtraction. So if I have something with addition, my inverse operation would be subtraction, and vice versa. The opposite of subtraction would be what, class? Addition. So what if I had multiplication? If I had multiplication, the opposite of multiplication, would you agree, is division. And the same thing goes vice versa. If I have division, the opposite is multiplication. Now, where does this benefit me? Okay, let's start off with this. If I gave you a positive 5, if I am adding 5 to that variable, okay, what is the inverse operation of addition? We said it together. What is it, class? Subtraction. So what I'm going to do is I'm going to subtract this exact same number that I have. So if I have plus 5, now I'm going to have minus 5. And what does that give me? plus 5 minus 5, Jasmine, gives me
0.
0. It gives me nothing. I'm all by itself. You remember we talked about this actually, I don't remember when it was, maybe when we were doing adding and subtracting sign numbers. Remember the name that I gave you if I had a plus sign and a minus sign, just two different signs but the same number? Anybody remember what that name was called? Give you a hint, it starts with an A. It was an additive inverse. You remember that term, additive inverse? That's what these are. I'm just taking the additive inverse, I'm adding them together, and now I get 0. Hey, what happens if I add this x? If I add an x to that, well, if I add 5x minus 5x, I still have 0, don't I? 0x is the same thing as 0, okay? 0 is always 0. So that x is not even needed anymore. So as soon as I have that additive inverse, I can go ahead and make it 0. What if I gave you something like this? What if I gave you a negative 3? A negative 3. What would the opposite of negative 3 be? Then Clara, quickly to the microphone.
Positive 3.
A positive 3. And when you add those together, you're left with 0 for your answer. Okay? So that's what you're thinking of. That's what you're doing. You're just doing the opposite operation. Okay? So let's jump back over here to this problem that we're solving. X minus 10 is equal to 10. What is beside the x? You see I have a minus 10. So I want to get that minus 10 away from the x. So Michael, what am I going to do with that minus 10? Think using your inverse operations.
Add 10.
You're going to add 10. And then watch what you need to do. I put a star beside this in my notes. I'd put a star beside it in your notes. What you do to one side, you have to do to the other. What you do to one side, you have to do to the other. So what's done to one is done to both. What you do to one side, you have to do to the other side. All right, so come back over to this problem. If I added 10 to the left side of my equation, I also need to add 10 to the right side of my equation. Okay? And then watch what happens. I usually like to put a line here because now I'm going to simplify. All right? So what happens when I take negative 10 plus 10, that equals what, class? All participating, because we actually just practiced this again a minute ago, didn't we? Negative 10 plus positive 10 is what, class? 0. And those totally cancel out, and I'm left with, on my left side, you see I'm still left with x, all by his lonesome. Now he's isolated. Do you see that? There's nothing beside that x. Bring down your equal sign. X is equal to, and then you can help me out with this. 10 plus 10 is what, class? 20. And that's my answer.
Let's spend just a moment talking about how to teach a geometry proof. Now, we're going to spend just a little bit of time. Not everybody's going to be teaching geometry this year, so you may not be teaching geometry. But if you are teaching geometry, some of the concepts that we're going to talk about will help, because geometry can be one of those things that the proofs the students really struggle with. So how can you teach a proof so that the students are successful? One of the things that I have found is really helpful is to make it so that the students can attain it. And by that I mean give them little things that they can look for in a proof for them to look and see, okay, if I see this, this is probably the way I'm going to try to do it. One of the things that comes up at the beginning of the year in geometry is proving triangles congruent. And one of the proof statements that you're going to have is to get things equal, whether that's angles or lines. And a lot of times I'll tell my students, because that's the emphasis of that section, see if you can try to get triangles congruent. It's not going to always happen, but if it's something that if they see it as the proof statement, they can see that and say, hey, let me see if I can try it. It gives them somewhere to go. A lot of times if you are doing those proofs, you'll actually find there's lots of processes that follow after certain things happen. And you'll look for those and try to tell your students and actually have them take notes. It makes it not necessarily step by step, but something that is very attainable for them. So if they can look for those little things to give them as helps, that makes it so that not every proof is just completely different, because a lot of them do have very similar things that they're proving. And so there's general proof processes that you'll use in talking them through the analytical thinking that they're going to be learning. So if you can do that and make it attainable for them, it's a really helpful thing. Something else to think about is to practice proofs often, but not just you giving them the answers. And I know at the beginning, sometimes it takes quite a bit of you talking them through it and say, hey, this is what comes next. This is why I'm doing what I'm doing. But instead, see if you can get the students themselves to explain and give you ideas. Now, you may have to kind of go with what they're saying. And it may be that it doesn't lead to somewhere and you're thinking, I don't have time to do that. But it's a bit of learning curve that sometimes the students will have going into geometry. And so you want to make it so that they can see, okay, this is why this didn't work. This is where you're leading. And so you have to kind of know how much time you have in a class, and your goal is to make it as something that you practice often and that they understand that we're going to practice this as a class and I want you to help me with it. So everybody's thinking along and not just waiting for somebody to give the answer. So including all of them, having them all think, that is a challenge as you're teaching geometry, but your goal is to make it something that you practice often. One of the last concepts I would say is if your students are really struggling, especially at the beginning with proofs, see if you can provide more fill-in-the-blank proofs for them. The Abeka geometry book has quite a few that it starts off with, and if you use that same format, kind of leaning in maybe a bit more than even the book does if your class is really struggling, that will help kind of bridge the gap from them doing those fill-in-the-blank proofs to actually doing it on their own. Your goal is for them to really understand proofs. And if it takes a bit of more of those fill-in-the-blank proofs to see, this is my reason and this is why I have the statement that I have, that may help along the way. I have found that after using the fill-in-the-blank proofs, oftentimes the students do better by the time they've gotten into those proofs a little bit later in the year. Then they're able to do those proofs a little bit better because they've understood the foundation of how come things are what we're doing and a little bit longer than even the book has it. So that's a suggestion I would say. Maybe see about doing that if your students are struggling with it to help with the geometry proofs. Here to end, let me give you a couple of things that I have found if I'm leading into a class, this really does help. This year, these are some things maybe to try to emphasize as you're teaching. Be an encouragement to your students. So encourage your students in a couple of ways. One of the ways is to take notes and to memorize the steps, because if they do those two things, they can be successful. Now, success in math class may be that a student gets an A. They may not get an A, but they can understand the concept better if they take notes and if they're practicing and if they're memorizing the steps. So it may take a little bit harder work for some students to be successful at math than others, and that's okay. But your goal is to help them succeed. And so if you're able to really encourage them, hey, if you'll do this, you'll start to see that it really does help. They'll start enjoying class because they're successful at it. So that's something I would encourage you. And we started this way, and I said we'd come back to it, but encourage your students to actually learn about God, Creator, through the study of math. A lot of times you can teach a math class without them really seeing that God as Creator created this to describe His creation, and you can learn about God through His creation. So we're going to talk about that in just a moment. Encourage your class this year to actually learn about God by you teaching your students about God. So as you're going through and you're preparing your lesson, look for ways that you can point out God as Creator and His characteristics to your class. We'll talk about a couple of ways that you can do that. Show them His amazing order and design that's in His creation. You can see that in those real life examples in pointing out to them that there's so many applications to this in sciences, but also in just the way that the math is done. That order is not a coincidence. You consider the fact that God has created this so that I can literally give you steps that you can follow and the problem will work out if you don't make a math error. That's an amazing thing. But God created it that way. And so pointing out those things is a really helpful thing to your students for them to learn. This is not by chance that this is being done. Explain the characteristics of God that can be easily seen through His creation. And so you can see His power. You can see, and I know it's not a science class, but because math and science go so hand in hand, and a lot of times the applications are in sciences, you can point out those amazing things. One of the best things I have found is when we're going through homework and a student does a problem following math concepts we've done, but maybe it's a different problem and they happen to bring up something that's related to it. Pointing out the fact that because that student followed that same order, they followed the same processes we had done, and it's related that same way, it came to the right answer, and saying, That's something that God has created math to be able to do that, and it's an amazing thing to pause and say, isn't it great that we serve a God that has the power and the knowledge to be able to create this? One of the last things to do is to point out the fact that the details do actually matter. So spending time taking notes, taking neat notes so that you can read them later on, thinking through the processes and actually learning the details of that process really do matter. So whether that's units at the end of a number, whether that's making sure that you're getting the little details, and when you take the square root, putting positive, negative, all the details matter. The details mattered to God when He created, the details should matter in your class as well. All of those things, I would encourage you this year, see if you can point those things out to your students. One of the verses that I like to read, especially at the beginning when I'm going into a math class, is this, Deuteronomy 32:3. Because I will publish the name of the Lord, ascribe ye greatness unto our God. This year, I hope that you have a great school year teaching math, but I also hope that you ascribe greatness unto our God so that your students learn more about God as the creator, and as you're teaching those math classes, that you have a successful year, that your students succeed. Thank you so much for joining us today.